Hi, today I'm going to be teaching further maths. I'm doing the Edexcel specification. I'm starting with the core module. Today I'm doing chapter 4, which is roots of polynomials. So to start off, we're doing roots of a quadratic equation, and a quadratic equation we know is formed ax squared plus bx plus c equals 0. And if you remember from the complex numbers chapter, we can see the same equation formed with the roots. So you see ax squared minus a, brackets alpha plus beta x, plus a alpha beta equals to 0, where alpha and beta are the roots and a is the coefficient of x. And so there are two equations that can be summed from that, which is alpha plus beta equal to minus b over a, because we can see that by putting these two equations together, because they're equivalent. And then we have alpha beta equal to c over a. And so we see that one of them is minus and one of them is positive, and that's because it correlates to the equation, where there is a minus here and a plus here. So it alternates, and we'll see that when we go on to quartic, cubic. So here's a typical quadratic equation where we have 2x squared minus 5x minus 4 equal to 0. And you can see that 2x is the a term, minus 5, b term, minus 4 is c. And so we can now do the two equations that we saw before, where it's alpha plus beta equals minus b over a, and so minus b is minus 5. So we need minus 5, which is 5. And then over a, which is 2. So half plus beta is 5 over 2. And then alpha beta, or alpha times beta, is c over a, so that's minus 4 over 2, which can be simplified to minus 2. Okay, so now we move on to roots of cubic equations. So it's the same kind of form. So we have ax cubed plus bx squared plus cx plus d equal to 0. And so there are three roots, alpha, beta, and gamma. And so we do the same thing when we form the equation from the roots. So ax cubed minus a, brackets alpha plus beta plus gamma, x squared plus a, brackets alpha beta plus alpha gamma plus beta gamma, x minus a times alpha beta gamma equal to 0. So that's the same equation. And you can see again, it's the same thing where the pluses and minus alternate on every term. So we have minus, plus, and then minus again. And that goes into the three equations that are made from it. So you get the amount of equations for the amount of terms after a you have, basically. And so we have three equations. So it's alpha plus beta plus gamma equal minus b over a. And then alpha beta plus alpha gamma plus beta gamma is c over a. So that minus positive. So it's the first one's negative, the second one's positive. And then we have alpha beta gamma, which is minus d over a. So that one's negative again. And you can see that the terms kind of go in order of, so it's all of them added together, and then it's like 2 times together and added, and then it's all 3 of them times together, and you'll see that again for quadratic equations. Okay, because we already did practice on quadratic equations, and this is very repetitive once you get it. I decided to skip straight over it, so you should go and do practice yourself. So we're moving on to quartic equations, which are very similar. You know, x to the power of 4 plus bx cubed plus cx squared plus dx plus e equals 0, with 4 roots, alpha, beta, gamma, and delta. And so we formulate the same equation where minus a, and then all of them added is term b, x cubed. And then the second one is plus, and it's them doubled and added. So alpha beta plus alpha gamma plus alpha delta, blah, 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 keeps going. That's the second term, which is c. And then we have minus for the next one, and then it's the triplets. So alpha beta gamma, alpha beta delta, alpha gamma delta, beta gamma delta x, so that's d, and then all of them times together because that's the fourth one, and that's alpha beta gamma delta. And so you see it's plus minus type, so it's alternating again. And so that means you have 4 equations because there's 4 terms after a. And so the first one is all of them added is minus b over a, because you see it alternates. And then we have the doubles added together, and that's c over a, positive c over a. And then we have the triplets added together, and that is minus d over a, and then we have all of them times together, and that is e over a, positive e over a. So, you know, minus b over a, positive c over a, minus d over a, and positive e over a, and that works the same way with the equation where it's minus the second term, add the third term, minus the fourth term, and add the 5th term. Okay, so the next thing I'm going to talk about is expressions, because you get stuff in questions that doesn't always look like stuff you know, and so you have to instead form it into equations that you know. So here we have reciprocals, so you'll often get 1 over alpha plus 1 over beta, and you have to then turn that into alpha plus beta over alpha beta, which then you see is 2 equations that you already know, so that's minus b over a divided by c over a, and then that works for all of them. where you do the one before them all being times together. So, you know, for cubic, it's the doubles added together, and for quartic, it's the triplets added together over the total times together. So for cubic, it's c over a divided by minus d over a. And for quartic, it's minus d over a divided by e over a. And that's just something you need to know, because when you see it, you will need to then change the equation and form it into something you know, and then work with it from there. Okay, this is another expression that you will see, and it's very easy. So it's just that for any of them, if you have the roots times by the same power, you can just do them added together. So if you have... Okay, so this is another simple expression, and it's basically just where you have the roots added together to any power. They can just be added together, and the total can then be times by the power, because you know how to add them together, because that's in the equation. And so, okay, so here's another expression you need to know, and it's the products of powers. So basically, it's that if you have any of your roots times together, let's take the quartic, where you have alpha to the power of n plus beta to the power of n plus gamma to the power of n. Okay, so now here's the equation for the sums of squares, which is different to the one you saw before, because instead of them being times together, they're added together. So you have to form it into an equation that you know. So you do alpha plus beta, the whole squared, and then you have to minus it. So you basically have to complete the square on all of these. And that is how you form the equations. Yeah, so you just have to remember that and do it. Okay, and this is the same thing, but for the sum of cubes. I do want to say before that you don't have to know the sum of cubes for quartic equations, so it's only quadratic and cubic. And you have a similar thing where basically you have to do alpha cubed plus beta cubed plus gamma cubed in the case of cubic. And you have to then make that into an equation you know. And so that's alpha plus beta plus gamma, the whole cubed. But obviously you only want those 3 terms cubed, so then you have to take out everything else that isn't that, basically. And so you can multiply out the equation and figure it out that way, or this is the base equation that you could remember. You can do it either way, it's just the case of knowing how it works and how to do it if that equation comes up. Okay, so now moving on to the linear transformation of roots. And I decided to go straight into a question because it's hard to understand without an example. And so linear transformation is where you have an equation with roots, and then you have to find the equation with a different set of roots. So that can either be the original roots times by something or added to something. Okay, and so for this first one, we're going to do this equation with roots 2 alpha, 2 beta, and 2 gamma, because this is a cubic equation. Okay, I do want to say that all of the roots will always be treated with the same function. So if they're multiplied, all of them will be multiplied by the same number. And if a number's added to them, all of them will have the same number added to them. Okay, and so this helps with the method that I use. So we're going to take a random value, let's say w is equal to 2x, because all of them are multiplied by 2. So that means that x equals to w over 2, w cubed over 8 minus 2 brackets w over 2 the whole squared, add 3 brackets w over 2 minus 4 equals to 0. So this means we have w cubed over 8 minus 2w squared over 4, or w squared over 2, add 3w over 2 minus 4 equals to 0. And we always want the final answer to be an integer, all in integers. So we have to then multiply it through by the biggest denominator. So in this case, it's 8. We have to multiply it through by 8. So then we end up with w cubed minus 4w squared plus 12w minus 32 is equal to 0. And that is the equation with roots 2 alpha, 2 beta, and 2 gamma. Okay, so now we're going to do the same thing, but instead of having the roots multiplied by something, I'm going to have them added to something, just so you know it works both ways. Okay, so now if you remember the method from before, we're going to do w equals to x plus 2, because all of the roots are plus 2. That means that x equals to w minus 2. And so we have to substitute that in. So that is w minus 2 cubed minus 2 brackets w minus 2 squared plus 3 w minus 2 minus 4 equals to 0. And this is the solution it makes. I quickly render it just to save time, but this is what it makes. And this is then the solution, the equation with roots, alpha plus 2, beta plus 2, and gamma plus 2. So that is all you need to do. You need to just substitute and solve. That's it. And that's what you do for any linear transformation. And that is all you have to know for the roots of polynomials. So thanks for watching. Go do some practice questions. Bye.